Hi, my name is JasonHopper. I am going to be discussing section 18.2 of chapter 18, the replications. And this section, basically, the main thing in this section is to describe the replication process, the system, and basically how it works with group communication by achieving like a fault tolerance with the replication. One of the first steps here is understanding what replicas are. They're basically a collection of physical copies of logical objects that are found on a system. If you don't know what logical objects are, they are a collection of data in our system, such as a file or Java object. The next step here is the actual replication system model. The basic model for it is clients, front ends, and replication managers. Your clients are going to be someone like you or me that's wanting some information online or something like that. Your front end managers are kind of like the middleman. They have a talk between the clients and the replication managers. They handle the client's requests first before anything else. They communicate with the replication managers, as I said, and they will either communicate with one or many, depending on what the client requested. The front ends also act as a way to make the whole replication process transparent, and they can be found in either the user's address space or a separate process altogether. As for your replication managers, they're basically replicas. They're replicas of the data that's on the computer, more or less, and they perform operations on them directly. In a client server system, they would more or less be the server. Your phases of replication requests. There's actually 5 phases. You have request, which is basically where the front end sends a request to the replication managers. After this, they go into the next section, which is coordination. This is where the replication managers coordinate to basically process the request that was asked of them. After that, you have execution. And honestly, from what I got from reading it, it's not quite a full execution. It starts the execution process, giving enough leeway pretty much for the replication managers to decide whether or not to fully commit to it or to abort it, which is your next section, agreement. And this is where all the replication managers decide that they can either go ahead and let the execution completely go through, or they will abort that request altogether. Next section after that is where the replications managers will send a response to the front end managers of what they decided. The next section in this section is basically your role of group communication. This basically discusses how replication works with group communication and fault tolerance. If you don't know what fault tolerance is, it's basically any system that has the ability to adapt to a process such as a join, leave, and crash. Basically joining a group, leaving a group, or if the system crashes. Your group views, which is what we have to go into here, are basically lists of the current group members. They have unique identifiers to them. They could be basically a login number, or just maybe a number of the person who joined. Say there's 4 other people ahead of this person. This person joins the group. Now they're number 5. That's their identification number. Our next step is your view delivery and view synchronous group communication. View delivery requirements, they are order, integrity, and non-triviality. Those are your requirements, your basic requirements for view delivery. You have to have these in order for that delivery to be viewed, to that view to be delivered. I'm sorry. The first process, order, it's giving the program a consistency guarantee. It ensures that the view changes always occur in the same order at different processes. Your next one, integrity, is pretty much anything else. The book describes it as a sanity check, and it basically helps keep the integrity of this view together. Your third one basically guards against trivial processes. Trivial process, two groups that don't have much authority or whatever that are communicating with each other, they're trivial. There's nothing really going on with this group. It will basically group those trivial processes together and put them in one group for communication processes. Your next section is view synchronous group communications. View synchronous group communications, it basically makes additional guarantees about the delivery ordering of view notifications with respect to the delivery of multicast messages. Basically the guarantees provided by this are agreement, integrity, and validity. Agreement, the correct processes deliver the same sequence of views and the same set of messages in any given view. Basically, if a correct process delivers a message in a view, then all correct processes that deliver that same message also do it in that same view. Integrity. This part is basically if a correct process basically delivers a message, then it'll not deliver that message again. That's basically with all your other integrity. It's basically making sure that it doesn't keep delivering stuff. Make sure it stays strong. Then you have validity, which are closed groups. It's make sure correct processes are always delivered the messages that they send. And this one basically, if you see in the figure off to the side, you got processes P, Q, and R. If you look at it, P is trying to send a message M while in a view, but it crashes before it's able to send that message. This is part A here. What the system will basically do, it won't send that message. It will go ahead and let view, Q, and R go, and eventually when it reconnects, it will send the message P. It's basically showing that this is an allowed option under that. Your section B, the messages basically get sent to maybe one or the other before it crashes. In this case, it will send the message before it sends the view, Q and R. And then section C, if you look on there, it basically is saying that the view cannot, the messages go through, but the views are not allowed to be sent before the messages. And number D, it won't deliver the messages out of order. This is basically how it keeps it synchronous. It's not going to send anything out of order. That's basically what this whole section is. And it's more or less discussing how this whole process goes. And this is the end of my section. We'll go on to the next section, which is fault tolerance services provided by another member of my group.